Hello friends, welcome to engineering tutorial. So we'll continue our discussion related to error analysis of non-unity feedback systems. So this is another question where it has been given that we have a system where the forward path transfer function gs is equal to 1 by s square into s plus 12 and the feedback path transfer function is 5 into s plus 1 by s plus 5, and we have to find out the steady state error due to step and ramp input. Okay, so we'll do the usual thing. So in case of non-unity feedback systems, in that case we know that the error equation is given like this: kh es is equal to rs minus kh cs. So here this kh term, which is called as the DC gain of the feedback system, that is given as limit s tends to 0 hs. So here it will be limit s tends to 0 hs, which is 5 into s plus 1 by s plus 5. Okay, this. So here kh is equal to 5 into 0 plus 1 by 0 plus 5, which is 5 by 5, which is equal to 1. Kh is equal to 1. So here if you write the error equation in a better way, it will be Es is equal to Rs by Kh minus Cs. So if we take Rs as common, then it will be 1 by Kh minus Cs by Rs. So here it is equal to Rs into 1 by Kh. Cs by Rs is the closed loop transfer function, we all know that. So that is Gs by 1 plus Gs Hs. So here we'll go step by step. First we'll consider the step input, then the ramp input. So here the important thing is to evaluate this 1 by Kh minus Gs by 1 plus Gs Hs, this much portion, because then we'll substitute Rs with 1 by s for step input and 1 by s square for ramp input. Okay, so now our focus is 1 by Kh minus Gs by 1 plus Gs Hs. So this much we want to evaluate: 1 by Kh minus Gs by 1 plus Gs Hs, because it is common in both the cases. So that will be equal to 1 by 1, which is 1, Kh is equal to 1, minus Gs, which is equal to 1 by s square into s plus 12 by 1 plus Gs Hs. So that will be 5 into s plus 1 by s square into s plus 12 into s plus 5. Okay, this. So here it will be equal to 1 minus 1 by s square into s plus 12 by, here it will be in the denominator, it will be s square into s plus 12 into s plus 5. Here it will be s square into s plus 12 into s plus 5 plus 5 into s plus 1. Okay, this. So here s square will get cancelled, s plus 12 would get cancelled, and this s plus 5 will go into the numerator. So again it will become 1 minus s plus 5, okay, 1 minus s plus 5 by s square into s plus 12 into s plus 5 plus 5 into s plus 1. This is the equation that we want. 1 by kh minus gs by 1 plus gshs, this much portion, okay. Then we'll substitute rs with 1 by s for step and 1 by s square for ramp, okay. So here in this portion for step input, this is what we require, this much portion, this, okay. So here for step input, unit step input we are talking about, so the rs will be equal to 1 by s, unit step input. So here es, okay, es is equal to rs into 1 by kh minus gs by 1 plus gshs, okay. So here we know that steady state error is equal to limit s tends to 0 s es, okay. So here it will be equal to limit s tends to 0 s into rs, which is equal to 1 by s into 1 by kh minus gs by 1 plus gshs, which is equal to 1 minus s plus 5 by s square to s plus 12 into s plus 5 plus 5 into s plus 1, okay, this much. So here ss will get cancelled because they are in numerator and denominator respectively. So when we substitute s with 0 here, it will be equal to 1 minus 0 plus 5 by 0 square into 0 plus 12 to 0 plus 5 plus 5 into 0 plus 1. So anything multiplied with 0 will become 0. So it will be 1 minus 5 by 0 plus 5, which is equal to 1 minus 5 by 5, which is equal to 1. So 1 minus 1, it is equal to 0. So the steady state error for this non-unity feedback system for step input, that is equal to 0, okay. This is for step input only. Then we will substitute for ramp input. So very easy. Remember, everything else is fixed up to this point. We have to first figure out this 1 by kh minus gs by 1 plus gshs, which we have calculated as this one. All we have to do is substitute rs. For ramp input, it will be equal to 1 by s square. For unit ramp input, it will be 1 by s square. So just like we substituted rs with 1 by s for step input, for ramp input we will substitute it with 1 by s square. So let us do that. So in this case, for ramp input, we just have to substitute this with 1 by s square. So here it will be, the steady state error will be limit s tends to 0 s es. So here it will be limit s tends to 0 s into 1 by s square, okay. In place of rs we substituted 1 by s square, and 1 by kh minus gs by 1 plus gshs, that will substitute it with this. So it will become one minus s plus 5 by s square into s plus 12 into s plus 5 plus 5 into s plus 1. So this can become a little bit tricky, okay. We have to simplify and do a lot of things. So first let us cancel this with 1 by s, okay. So now we will take it here, perform some simplification process. So that will become limit s tends to 0 1 by s into s square into s plus 12 into s plus 5 plus 5 into s plus 1 minus s plus 5 by s square into s plus 12 into s plus 5 plus 5 into s plus 1. Okay, this. So now you have to do these calculations very carefully, okay, because at any moment if you make one single mistake and this whole thing it will be wrong, okay. So for that reason you do the simplification process very calmly, coolly, do it step by step, you complete the whole process. So here when we simplify it, when we solve this, okay, when we solve this, this will become limit s tends to 0, 1 by s into the numerator will be s4 plus 17s cube plus 60s square plus 4s. Okay, I have already solved it, so that's why in order to save time I just did it quickly, because just simple calculations, okay, so there is no need to do this, you can do it, so just do it step by step. And in the denominator it will be s4 plus 17s cube plus 60s square plus 5s plus 5. Okay, this much. So here when this s gets divided with this numerator, this will become limit s tends to 0, this s gets divided everywhere in the numerator, so it will become s cube plus 17s square plus 60s plus 4, okay, by the denominator is just the way it is, s cube plus 60s square plus 5s plus 5. So now when we substitute it with 0, it will become 0 plus 0, 0 cube plus 17 0 square, which will be 0, plus 16 to 0, here will be 0, plus 4 by s to the power 4, that is 0 to the power 4 is 0, 17 into 0 cube is 0, 16 into 0 square is 0, plus 5 into s, 5 into 0 is 0 plus 5. So it is 4 by 5, which is equal to 0.8. So here the steady state error for this non-unity feedback system for unit ramp input is equal to 0.8. This much. So here the important thing is first be clear about this equation, okay, then here both step and ramp inputs, they are applied. So here the important thing is to get this common term 1 by kh minus gs by 1 plus gshs. First find out this common parameter which is involved, then this rs part you just have to substitute rs is equal to 1 by s for step input, then find out the steady state error limit s tends to 0 SCS, then again substitute this rs with 1 by s square, okay, rs is equal to 1 by s square. Here for ramp input rs is equal to 1 by s square, we know, because step input rt is equal to ut aut and a is equal to 1, that's why it is 1 by s, and for ramp input rt is equal to at. So here as a is equal to 1 unit ramp input, it is simply t. So 1 by s square, the Laplace transform, and we just substituted 1 by s square rs, and then we figured out how to find out the steady state error using this formula, final value theorem, and we got the result. So for ramp input it is 0.8, a finite value, and for step input it is 0. Okay, so I hope you like this video, and please subscribe my channel Engineering Tutorial for more such videos related to engineering, science and technology. Have a great day. Thank you very much.